Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izhar bin Nozahari. Number metri AA190338. I'm from section 7 and group number 6. So my part is BJT. So I will tell about introduction first. The BJT stand for bipolar junction transistor is an electronic device that has 3 terminals and used in different amplification circuit. It also known as a current controlling instrument. Its 3 terminals are emitter, base and collector. Also have 2 PN junction. The junction formed through the base and emitter called base emitter junction, and combination of base and collector make the base collector junction. Okay, there are 2 further type of BJT. First is NPN and the second one is PNP. These type are designed according to doping level as it used in for amplification process. For this it needed an external DC source. Okay, we move to structure. The bipolar junction transistor is manufactured with 3 semiconductor regions that are doped differently. These 3 regions that have doped differently are known as the base, collector and emitter. The base region is lightly doped and is very thin compared to the collector and emitter regions. The collector region is moderately doped while the emitter region is heavily doped. Okay, we can see from this picture. Okay, this picture presenting NPN, PNP, BJT physical representation bipolar junction. Okay, transistor can be an NPN or a PNP type. The NPN type consists of 2 N regions separately by a P region. The base region is the P-type material, while the collector and emitter regions are N-type material. In PNP type, the transistor consists of 2 P-type regions, the collector and emitter, separated by N-type base regions, regardless of the transistor. Okay, DC voltage to operate properly. One of this junction is called the base emitter junction, connecting the base and emitter regions, and the other one is the base collector junction, connecting the base and collector regions. Okay, operation of BJT. For an understanding of the working of BJT transistor, let's discuss the internal structure of NPN transistor. In the picture, you can see that the emitter part, which is N-type of a transistor, is highly doped and has a large number of free electrons. Free electron of N region will enter into the base, which is a P-type and has less area, through the forward bias base emitter junction. It represents in a picture through a white arrow. The base of the transistor has less number of holes that are also majority carriers shown through white color circles. Some electrons enter in the base region, combine with the hole and move like valence electron in base and in emitter as hole current shown in a picture through red color arrow. The electron combine with the hole axis from the structure of a base. They move like free electron in the metal base lead and generate an interior base current. Due to less area of base, mostly electron enter in the base do not combine with the hole. When electron move towards and base collector junction, which is the reverse bias condition, this electron move to the collector due to the positive voltage across the collector. Okay, electron enter the collector region in the exterior a circuit, and after this enter in the emitter of a transistor with the base current as represented in the picture. The emitter current is somewhat larger than the collector current since of the less base current that divide from the total current into the base region from the emitter. Okay, other that configuration type. Okay, configuration type have a three divided to three. Okay, first, common base configuration has voltage gain but not current gain. Two, common emitter configuration has both current and voltage gain. Third, common collector configuration have current gain but not voltage gain. Okay, I will elaborate it. First, the common base configuration. As its name suggests, in the common base or ground base configuration, the base connection is common to both the input signal and the output signal. The input signal is applied between the transistor base and the emitter terminus, while the corresponding output signal is taken from between the base and the collector terminal as shown. The base terminal is ground or can be connected to some fixed reference voltage point. Okay, second, the common emitter configuration or CE. In the common emitter or ground emitter configuration, the input signal is applied between the base and the emitter, while the output is taken from between the collector and the emitter as shown. This type of configuration is the most commonly used circuit for transistor-based amplifier, and which present the normal method of bipolar transistor connection. Okay, number 3, the common collector configuration. Okay, in the common collector or ground collector configuration, the collector is connected to ground through the supply. Thus, the collector terminal is common to both the input and the output. The input signal is connected directly to the base terminal, while the output signal is taken from across the emitter load resistor as shown. This type of configuration is commonly known as a voltage followers and emitter follower circuit. Okay, so this is generally a characteristic of the different transistor configuration given in the following table. Okay, so we continue with other part that market price analysis of transistor 2N2907. Okay, so this is a graph of analysis price market. So this is that graph analysis. We can see for the first part is not increase, and at the middle the increase, and at the end decrease again. So okay, we move to data sheet. So from the data sheet, I get it from Google reference. So this is for amplifier transistor 2N2907. So that represent about a maximum rating, thermal characteristic, electrical characteristic, on characteristic, off characteristic, small signal characteristic, switching characteristic. So this is about data sheet in my transistor, that my group transistor. Okay, that's all from my part for BJT. Thank you.
Hi, Assalamualaikum. My name is Muhammad Amzal Syamil bin Zaki. My matric number is AA190061. I'm from section 7. Okay. Today I want to explain about uh, my own project. Um, in this our project, I got a part of field effect transistor or JFET characteristic. Okay, first I want to go through the introduction of JFET. Okay, in JFET, as now a junction field effect transistor is a unipolar voltage control device that consists of three terminals that is called a drain, source, and gate. Unlike bipolar junction transistors, which are bipolar current control device in which small amount of base current is used to control the large amount of current at the collector and emitter side. JFET is a unipolar voltage control device in which voltage applied to the gate terminal allows the current to flow through JFET, resulting in the input applied voltage equals to the current flowing through the transistor. Okay, the operation of JFET depend on the electric field by input applied voltage, hence it is called a field effect transistor. JFET also can be classified into two types, N-type and P-type JFET. In JFET, current carrying path between drain and source is called channel, which contains non-PN junction. Channel can be made up of P-type or N-type semiconductor. Current flowing through this channel widely depend on the input voltage applied to the gate terminal of JFET. Field effect transistor generally comes into two types, JFET and MOSFET. As stated earlier, JFET contains no PN junction, and instead it comes with channel that consists of an P-type or P-type semiconductor that pass between source and drain terminals of JFET. Okay, next is JFET structure. JFET structure have two types. First, N channel. The channel is doped with the donor impurity due to this current passing through the channel is negative. N channel has more current conduction because the mobility of electron is greater than the mobility of holes. The channel is widely used. Okay, for P channel, the channel is doped with the accepted impurities due to this current flowing through this channel is positive. P channel has less current conduction. The channel also is less widely used. Okay, and in this picture is show about N channel and P channel JFET construction. Okay, next I'll go through to JFET operating characteristic. Okay, there are three basic operating conditions for a JFET and channel. First, VGS equals to 0, with VDS increasing to some positive value. Second, VGS less than 0, where VDS at some positive value. And third, voltage control resistor. Okay, for N channel JFET, VGS may never be positive because VGS a reverse bias input. Okay, in VGS equal to 0, where VDS increasing to some positive value, this depletion region produce a potential gradient with the variation of thickness around the N channel and P channel. This both channel will oppose the current flow through the channel by reducing the channel width and by increasing the channel resistance. Okay, for the in this case, in this case of VGS equal to 0, where VDS increases to some positive value, have a pitch off and saturation. Okay, for pitch off, if the VGS equal to 0 and VDS is further increased to more positive voltage, then the depletion zone gets so large that it pinch off the N channel. Okay, for the saturation at the pitch off point. Okay, any further increase in VDS does not produce any increase in ID. VGS at pinch off is denoted as VP. Okay, ID is at saturation or maximal because it is referred to as IDSS. Okay, the ohmic value of the channel is maximum. Okay, for the VGS less than 0, where VDS at some positive value become more negative, the JFET experience pitch off at a low voltage. ID decrease, where ID less than the IDSS even though VDS is increased, and eventually ID reach 0 ampere. VGS at this point is called VP or VGS off. Okay, for the basic, for the last basic operating condition for JFET is a voltage control system. The JFET can be used as a variable resistor where VGS controls the drain source resistance. As VGS becomes more negative, the resistance is increased. That's all is for operating and channel JFET. Now this is operating characteristic for P-channel JFET. The P-channel JFET is a JFET whose channel is composed primarily of holes as the charge carrier. This means that when the transistor is turned on, it is primarily the movement of holes which constitute the current flow. The P-channel JFET is composed of a gate, a source and drain terminal. As VGS is increased more positively because the depletion zone increase, and ID decrease, and eventually ID equals to 0 ampere. This picture above show the height level of VDS. The JFET reach a breakdown situation. Yes. Okay, now next go to the JFET configuration basics. The three different JFET circuit configuration are the common source, common drain, and common gate. Okay, first go to common source. First, common source is probably the most widely used. The common source circuit provides a media input and output impedance level. Both current and voltage gain can be described as medium, but the output is the inverse of the input. This provides a good overall performance, and as such, it is often thought of as the most widely used configuration. Okay, second is the common drain. Common drain, also known as the source follower, it because the source voltage follows that of the gate, offering a high input impedance and a low output impedance. It is widely used as a buffer. The voltage gain is unity. Although current gain is high, the input and output signal are in a phase. Last is a common gate is provide low input impedance while offering a high output impedance. Although the voltage is high, the current gain is low and the overall power gain is also low when compared to the other FET circuit configuration available. The other salient features of this configuration is that the input and output are in a phase. Okay. This is a market survey. This is my JFET is used in this project. The code of JFET is 2N3458. Okay, and here we can see the price where buy one can get 15 USD, while buy two can get 13 USD. Okay. Next, this is a data sheet. In this data sheet have features, application and description, product summary, and ordering information. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Syafiq Aiman bin Suzaha. Nombor metrik AA1900001 dari Seksyen 7. Okay. Di sini saya akan menerangkan untuk soalan yang ketiga. Okay. Untuk soalan ketiga ni terdapat 2 point, iaitu construct a comparison table of BJT and JFET as amplifier application. State an example of bond type where the amplifier circuit are implemented in industry and market. Okay, itu untuk poin yang pertama. Dan poin kedua ialah give an example of voltage divider biasing circuit for common emitter amplifier BJT and common source amplifier JFET. Please discuss the relate formula that involve and show the detailed calculation. Okay, itu untuk poin yang kedua. Okay, untuk dalam PowerPoint ni terdapat untuk poin yang pertama saja. Poin yang kedua terdapat di bahagian lain. Okay, jadi kita teruskan untuk poin yang pertama dahulu. Okay, ni adalah comparison table between BJT and JFET. Okay, di sini terdapat simbol untuk BJT dan JFET. Okay, carrier untuk BJT ialah bipolar. Okay, carrier untuk JFET ialah unipolar. Okay, untuk device type untuk BJT current controller device, dan the device type untuk JFET adalah voltage controller device. Okay, untuk power consumption untuk BJT it consume more power. Okay, untuk JFET pula it consume less power. Okay, input impedance untuk BJT ialah low dan untuk JFET adalah high. Untuk noise level untuk BJT high, manakala untuk JFET low. Okay, thermal stability untuk JFET low, manakala untuk JFET high. Okay, gain untuk BJT high gain dan untuk JFET low hingga medium gain. Okay, low hingga medium gain. Okay, untuk size BJT large dan untuk JFET small. Okay. Application preference untuk BJT, it is preference in low current application. Manakala untuk JFET, it is preference in low voltage application. Okay. Using a BJT as a switch example. Okay. Suppose we had a lamp that we wanted to turn on and off with a switch. So a circuit will be extremely simple as in the figure below. Okay. Next, for the sake of illustration, let's insert a transistor in place of the switch to show how it can control the flow of electron through the lamp. Remember that the controller current through a transistor must go between collector and emitter. Okay. Maksudnya, since it is the current through the lamp that we want to control, we must position the collector and emitter of our transistor where the two contacts of the switch were. We must also make sure that the lamp current will move against the direction of the emitter error symbol to ensure that the transistor junction bias will be correct as in the figure below. Okay. Ni adalah gambar untuk BJT lah. Okay. Okay. Yang pertama tu A tu untuk mechanic switch, dan B tu untuk NPN transistor switch, and C PNP transistor switch. Okay. Okay. Ni adalah huraian dia. A PNP transistor could also have been chosen for the job. Its application is shown in the figure above. The choice between NPN and PNP is really arbitrary. All that matter is that the proper current direction are maintained for the sake of current of correct junction biasing. Okay. And last one, in the above figure, the base of either BJT is not connected to a suitable voltage and no current is flowing through the base. Consequently, the transistor cannot turn on. Perhaps the simple thing to do would be to connect a switch between the base and collector wire of the transistor as in figure below. Okay, ni gambar dia. Itu untuk cut off, lamp off, dan B tu untuk saturate lamp off. Okay, untuk JFET pula. Okay, ni yang dia. One of the application of the JFET is a amplifier. It amplifies the weak signal connected in the gate terminal. The input is always reverse bias. A small change in the reverse bias of the gate produces large change in the drain current. This fact makes JFET capable of amplifying the weak signal. Okay. Okay, ni operation dia. Sebelum saya baca operation, dan ni adalah litar dia. Okay. Ni litar untuk JFET. Okay. Operation dia ialah when negative signal is applied at input of the amplifier, the gate bias is increased. The application diode is decreased. Channel resistance is increased. ID is decreased. Drop across load resistor is decreased. And the positive signal is present at output through C2. When the positive signal is applied at the input, the action will be vice versa. This means that there is phase inversion between the input signal at the gate and the output signal at the drain. Okay. Dan ni adalah litar dia. Okay. Okay. Selesai untuk poin pertama. Okay. Untuk menjawab poin yang kedua. Okay. Ni adalah untuk menjawab soalan poin yang kedua. Okay. Ini adalah contoh litar. Okay, contoh litar untuk mencari voltage divider biasing for common emitter amplifier, BJT. Okay. Okay. Ni contoh litar ni kumpulan kami mengambilnya dalam lab yang keempat. Okay. Okay. Dan ni adalah calculation dia. Okay. Di sini terdapat untuk mana okay? Untuk mencarilah VTH, IB dia berapa, IC, IE, VCE. Okay. 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 Untuk discussion pula, kumpulan kami mengambil komponen BJT 2N2907. Okay. Untuk mencari voltage divider. Okay. Untuk mencari voltage divider biasing for common emitter amplifier. Okay. Okay. Okay, ni lah. Okay, ni adalah contoh litar JFET. Okay. Untuk mencari voltage divider biasing for common emitter amplifier. Okay. Okay, dan ni adalah calculation dia. Okay. Dan di sini terdapat di sini kumpulan kami mencari nilai ID dan VGS. Okay, nilai ID 1.52 mA dan VGS dapat negatif 1.8 voltage. Okay. Okay, untuk discussion pula kumpulan kami menggunakan JFET 2N3458 untuk mencari voltage divider biasing for common emitter amplifier. Okay, JFET. Okay. Okay. Ni adalah reference bahan yang kami ambil untuk BJT tadi di dalam lab yang keempat. Manakala untuk JFET tepat dalam satu laman web ini. Okay. Okay, itu saja daripada saya. Sekian, terima kasih.